Hello, everyone. My name is Matt Gritt. Before we'll start, I'm just letting everybody log in for to get themselves acquainted. There is a chat function and a question and answers function. You should see them in the middle of your page. I will answer questions probably at the end of this live demo. And we're going to go through application observability demo. So I'm just waiting for more people to turn up. We'll probably get started in about a minute. Whilst we're waiting, if you want to put where you're from in the chat function, that would be good. I'm Matt Gritt. I'm based in Wellington in New Zealand. I'm a senior enterprise solutions engineer for Sumo Logic. Excellent. Well, let's just get started then. So over the next few minutes, I'm going to take you through application observability. We're going to go through a demo and a few things I want to sort of show you. So before we get started, I'm just going to flick through a few different slides, just basically showing you the kind of things that, what we've been hearing from our customers, the kind of the issues that they've been having. So, you're expanding tech stack, moving into the cloud, having these, disparate systems, it's rapidly getting more and more systems are coming online. This means you're exploding the number of components. You might be using Kubernetes or Lambda functions or Azure functions. And all of these things are producing more and more data. And there's so much data, it's like trying to wade through it, it's getting really, really hard. New things come on board, new technologies, Internet of Things and things like that are becoming more and more prevalent. So that rapid rate of change is really affecting how you keep up with these things. And also this means that, with all of these new devices, these new surfaces are being able to be attacked. So security is paramount. And a lot of the current sort of siloed tools are, they can't keep up. And this is why Sumo Logic is, trying to alleviate those problems. So the agenda for today is looking at quick and effective troubleshooting. I'm going to talk about service maps, traces and spans, logs, and then I'll sort of jump into sort of some global intelligence based on Kubernetes, but we do have other ones. So what is observability? Well, observability, as you can see, requires a lot of rich data, bringing it in, making sure you've got monitors are in place, so you can have alerts, and that mean time to investigation can be reduced. You've got to have that diagnosis of what is the context around what it is you're seeing, where it is, how long it's going on for, and things. That mean time to discover and that mean time to resolve. So those are really important parts of that whole sort of observability package. So this means that you're using your logs, your metrics, your traces, and your spans to get that whole kind of view of what's happening in your application. I just want to briefly touch on how we get the data into the system. So we have collectors. We have sort of two types of collectors. We have installed collectors, and these are the kind of things that you would install on a device, like an open telemetry collector, to gather that kind of information. And then that's pushed to us into our system, and then you can report on it and have visualizations on it. The other is a hosted connection. So that's kind of like your connection to AWS, Azure, GCP. We can pretty much gather data from anywhere. In the nearly 4 years that I've been working for Sumo Logic, there's not been a system that I haven't been able to get data from at the moment. Don't think this is the limit of what we can get from. This is just a nice little indication of where we're coming from. So Observability. It's built for observers by observers. We've tried to make it as UX friendly as we can. We get a lot of feedback. There are feedback mechanisms in the UI that allows you to, sort of raise your concerns or any suggestions you might have. All of our integrations that I'm kind of showing you are out of the box at the moment, so it's really quick to set up. The visualization and exploration of your data, we try to make that a very, very quick, clean way of being able to correlate across different sources, etc. And then we have our kind of machine learning and AI kind of things running across it to try and pull out those sort of insights and allow you to really get the most out of the data that you've got. So, and then once you've got all that data, what can you do with it besides, having pretty graphs and things, benchmarking it, making sure it's optimized, etc. So let's kind of just dive right in. So I'm just going to let you focus on what's going on. So I'm just going to go through this. So I'm going to walk you through a kind of scenario for being like an on-call engineer. I'm going to go through sort of like the concept of having an alert on a service level objective that you might have. It might have arrived in something like Slack or MS Teams or PagerDuty or ServiceNow. We're going to look at traces, we're going to look at the metrics and identify what's impacting our system. So I'm just going to jump over to this kind of what you'd probably see. So imagine that you've got an alert, a message has come in, you're an on-call engineer for a banking app, it runs in Kubernetes, it's in AWS, and you've got a payment service talking to an account service and a database. And these are all sort of mission critical things that you might be dealing with. So you get the alert comes up, could be a PagerDuty alert, and there's a link in the alert and you click on it and it will take you immediately to a service level dashboard that fired the alert. So let's have a look at this kind of dashboard that you can see here. So this is a service level alert on the payment services. We can see our error rate. We can see a kind of graph that shows the actual level of our percentage errors. And you can see that there's sort of this pink cloud. Now that's sort of a standard deviation around what we expect the values to be based on your previous data points. The astute of you might have seen this little pink triangle, which is an outlier. So the moment it has an outlier, we identify it and you can have that set up as an alert. In this case, this is the alert that was fired. We've seen that our error rate service level objective for our payment services has gone beyond what we expect it to do. So that's where we got the alert. So some of the most critical elements in any kind of alert is to see who's been affected. With this particular panel, you can see right away which of our customers have been affected, and that allows us to go and talk to our customer support teams so they can better support those customers with this particular issue. So we can see, some of the errors that might be affecting the clients. We can see the transaction volumes of what was happening, and it's gone down and cleared again. We can see this kind of thing. This is the amount of dollars transferred in our banking app. We're now looking at pods, and we can see here that we've got a number of pods, each having its own error rate. So you can obviously see that green is good, yellow is bad, yellow is not good, and red is obviously bad. And also down here, you can see pod memories and also pod CPUs. Obviously, the darker the color, you can see that the higher the value, or etc. So let's have a look at one of these. You can just click on one of these pods, and you can pull out some more information. We can see that we have, what this is the particular error rate. We can see that we can go and jump straight into particular logs for this pod. We have some recommended dashboards that say, hey, you might want to have a look at these. But one of the other ones is we have the entities associated with this particular pod. We can see that the container it's in, we can see the deployment, the service, and the namespace, the nodes, and the cluster that it's associated with. We can see, if we wanted to actually look at this particular container, we could open it up. We could actually look at its logs, searches. We can have a look at its traces, spans, some metrics, or our root cause explorer. We might get onto that a bit later. Or we can have it opened in our, our entities dashboard. And you can see that, we have the CPU usage and the memory usage for that particular pod. We can also see that we haven't got any, crash loop backoffs happening, which is a good thing. Now, if it was just a single pod, I would probably dive deep into that single pod and see what's going on with that. But as you can see, we've got a number of pods that seem to be in distress. So this is probably something that's a bit more consistent across the entire deployment. So if that's the case, I might want to have a look at our service map to see what's going on in our deployment, what's going on, for those particular pods in the system and the services. So what I'm going to do now is I'm just going to open up our service map. You can see that we have various different systems running in our thing, but I'm just going to focus on our default banking app at the moment. And I'm going to zoom in a little bit so we can see these. So here you can see that we have a payment service, we have a transaction service, and we have an account service. The payment service is definitely talking to the accounts and to the transactions, but there's an inactive communication between our transaction service and our accounts for this particular time period. And we're looking currently at the last 72 hours. I could change this if I wanted to. The larger the size of the circle is the number of requests coming in, etc. And if we wanted to change the way this is being presented, we can. At the moment, this is reporting on latency errors, latency issues. We could have it go to errors. You'll see update, or requests. Or we could have it on our worst case scenario, which is if any of them are bad, indicate. And we can change some of the other variables if we wanted to give us more granular detail. So I want to look at the accounts. I'm just going to sort of pull that out now. So this is the accounts details. We can see the latency, the requests, and the errors. This is sort of like we've got a 100% error rate, so something is obviously very bad. What we could do is we could go and open this and actually go and have a look at the traces that are being produced. So the trace data is sort of transaction from start to end. Now, let me explain this, this display a little bit more. So we're looking at our default banking application. We're looking at the accounts sort of service, and we're looking at that particular time range that we've been having issues with. Now, all of these are the traces that have happened within that time period. So from the start of when somebody's started the payment service, what the actual root operation is, when it was started, how long it's been going, the number of spans, and this is sort of an indication of the span breakdown of, there's how much time has been allocated to the different types of spans. This is the number of errors and the status of those errors. What I'm going to do is I'm just going to sort of narrow it down a little bit more. And what I want to know is I'm just going to go for the number. I can't spell today. The number of errors And I'm just going to say, let's just make that greater than 5. So this is just going to pull back those traces that have more than 5 errors, because I want to kind of show you a little bit more. And what I'm going to do is I'm just going to click on this to actually give us something that has a lot of spans in. Yep. So let's have a look at this one here. So this is a payment service. It's doing a payments transaction to and from. It was at this particular time. It took 4 minutes and 46 seconds, and there are 17 spans. So I'm just going to click into that and have a look about what's going on in this particular instance. So we can see that this top bar is showing us the kind of the credible path contribution. So we can see that our SQL, MySQL mobile banking is taking 77% of the time. There's a little bit of an accounts taking about 22%, and then there's a little bit more in the payment service, which is just taking 1%. Now this diagram that you're seeing here, we call this an icicle chart, because these kind of little hanging bits, as you can see, they go down. So it's basically, this is what's happening first. These get fired, these gets fired, these gets fired as time goes on. So this is like the start, and this is the end. Now, the astute amongst you might have noticed there's a little red bar across the top of these. These are indicators that there are errors in the system or bubbling up. One of the ways that we can maybe see this a little bit easier is if I dull out the others, just to see where things are going on. So you can see here, I'm just going to pull in here, we had some SQL transactions, but they are not the issue. The lowest one we can find is this CRUD repository find by ID. So I'm going to click on that. I'll just move it across so you can see a little bit more. So I've clicked on it. Here we have summary of it. Again, you've got the status, the times. We could go and jump into the logs of these particular things. We can then click on the metadata of it. So not only do we have the span information, the tracing metadata that comes in, you can see that we're using Jaeger for our OpenTelemetry to gather the information. We can see that it's in our Kubernetes, and we can see exactly the pod ID, the pod is IP address, etc. And then our standard sort of Sumo Logic information that we have. We also have entities. So this is like where it sits in the hierarchy. So you can see here that we have this account service. You can see the latency, the requests, etc. We can see our application, the container, the pod, the deployment, the service, the namespace, etc. The node that it's running on. So we can actually get into any of those kind of data. We can actually go in and actually open them up how we want. I'm actually going to look at the accounts service container because that's kind of where I think everything's going on from the information that I've been presented with so far. I am going to open up this account service container. And actually, I'm going to just go and dive straight into those logs. So this is, the logs. Doesn't look like it's bringing any back. So again, this is our demo, a live demo. So let me just go back and see if I can pick something that's a little bit easier to do. Let's go back, hit our service map. Let's just check. Yep, that's latency, accounts. Yep. Open the traces. Number of errors greater than 5, because I want to make sure that we're getting quite good ones. Let's just pick a different one then. Let's pick this one. Okay, that seems to be the same one. Metadata, entities, and we are looking for the account service container. That should be right. And let's go and have a look at the logs. Excellent. So here you can see that we're looking at the actual logs from that particular container, that account services. And you can see here that it's gathered these results. There's only 398 different log lines in that particular time period. And this is where we might use our standard log reduce and log compare. So we'd click on this, and what it would do is it's going to go and look at the every single log line that has been brought back, and it's going to pattern match it, and it's going to try and create some signatures. These signatures are basically saying, hey, we've got 87 of these particular log lines, and the only changes in those log lines are that these sort of asterisks are different values. Everything else is the same. Now, one of the good things about this is you can readily see that instead of wading through 398 log lines, you're now looking at 7 lines, and you can see here that, okay, this is an information, this is a warning, oh, this is an error, and this is an error. So let's look at these errors to see what it is. So here we can see that could not open a JPA entity manager for the transaction, nested exception in the JDBC connection, too many connections. So we can see here that this is something that, hey, we've got too many connections going to our SQL container. Maybe this is something that we could just, quickly go and say, okay, allow it to have more connections, and then that would hopefully get around our issue. But this means that, as you've seen, very quickly I've gone from, hey, I've got an alert based on some metrics in the account service, the payment service. You can see that we've gone through these. We've looked at the service map to see what was going on with the various different services and how they communicate with each other. We've looked at the traces to see, what's been going on in the traces, which led us to the actual spans, and you can see what was going on. And then because we're looking at the spans, we've managed to get into the logs, and then we managed to get into, using our log reducers, basically allowed us to find that problem. So that's a really quick way of combining the metrics to tell us something's going wrong, the traces and the spans to tell us when and where it's gone on, and then the logs to finally say, hey, this is the reason why it's gone wrong. And now we can go off and fix the issue. Now, on the flip side of that, you can see here, we hadn't provisioned maybe enough connections to our database. But there are other ways that we can sort of, connect and not provision our systems quite so well. So what I want to just do is just step back a little bit and go through some slides. So one of the things that we have is this sort of global intelligence for Kubernetes. This allows us to benchmark and make recommendations on your Kubernetes setup based on the data that we've collected from around the world, and how efficient Kubernetes is, etc. Let me just jump into. It's probably easier if I just jump into the system. So I'm just going to close all of these down. I'll close all the tabs to the right, just so we can see that one later. And what I'm doing is I'm now going to open up our Explorer view, and I'm just going to go to our Kubernetes deployment view. So I'm going to go into our demo environment to see this particular cluster. This is, you can see that it's bringing back a kind of an overview of the CPU usage, memory usage, how many nodes we have, etc. But what I actually want to go down is into our banking app, into the namespace of our banking app, because that's what we were looking at earlier. So this is the namespace. You can see the various deployments underneath here. I'm going to look at the accounts service. So we're now looking at one particular deployment and the pods underneath it. Excuse me a second. Just taking a drink of coffee. So, so this is like our Kubernetes overview of our service account. You can see CPU usage. We're not using very much of what we've got. Memory usage, deployments. What is our replicas? Desired. How many we actually got? How many have we got? Unavailable kind of thing. And we've got some very basic stats for that to begin with. But what I really want to do is actually I want to drop down to say our optimization. I'm just going to make this 50 because it gives us a better sort of to show you a little bit more on it. So this is a really interesting dashboard. I find it quite interesting because this is basically talking to you about your risk profile and how much you set your CPU and your memory for the particular containers that you've got running all of your sort of systems. And you have that issue of, okay, well, if you have something over provisioned, it's going to cost you some money to keep them at that high level. And that might be an issue because of cost. But if you put it down too low and you under provision them via CPU or by memory, you have that risk of them falling over. We've got a lot of anonymous data on the Kubernetes. We've been able to look at these and base some information about what is the best way to look at those kind of CPU usage and memory usage on those containers so that you can actually give them a way of being more reliable or more cost or maybe a benefit kind of one. So we've got container memory. You can see that we've got here what our current memory stack is and our risk. And then we've got some ways of looking at this and saying, okay, this would be a more cost optimized view. If we set the memory for this value, we'd have this kind of risk percentage, which is better than we got at the moment. Or memory for this particular one is a balance, so balance between cost and reliability. And then reliability, we have a good indicator of where it is that having a memory of this particular size is you're not going to have that much risk. And then we can move down and we have to do the same for the CPU. Now you've got to remember that we've tailored this to be really kind of as cost effective for us as we possibly can with low risk. So you're seeing here the kind of, okay, this is how many CPUs. If you wanted to be cost effective, you could drop the CPUs down, but your risk percentage would be higher. This is, the balanced version between the two is kind of this pretty, it's the same because cost-wise you want to keep it the lowest. And then reliability, if you put the CPUs up, you're really going to lower your risk. Now, one of the other things that you can do is you could actually go for a more detailed view of your Kubernetes. And this works with any of the Kubernetes you've got, if it's EKS, AKS, doesn't make any difference kind of system, it's Kubernetes system. So again, this is a slightly different view of the same thing. And this is where we're kind of looking at that whole reliability. But one of the things I want to sort of show you, this is just more a graphical indication of the chart before. But one of the best ones is I find these tables really, really useful because this is when it goes into making recommendations for those kind of configurations and what you would, what you might want to look at for your different account services. And you can see, hey, if it's balance, you might want to do this. If it's cost, you might want to do this. If you want, reliability, you might do this. And you can see here, these are the values that you would then go, all right, these are the values I want. That's really, really good. I'm going to take those values and go back to our Kubernetes configuration and plug these in. because this is the real world data that basically says, hey, if you want to be more cost effective, set these values here, and then you'll be more cost effective. If you want to be balanced, they should be these, and if you want to be really reliable and not fall over, but you want to spend a bit of money on that reliability, then hey, these are the values you could do here. So that's pretty much what I've got for the global intelligence and Kubernetes. Just looking through these. You know, we know that we've got data from 17 million containers since mid-November 2020. We're able to work out, you know, what the risks is, the risk profile, and you know, for those 3 different types: the cost, the balance, and the reliability. So that's about it. If you have any questions, feel free to put them in the Q&A, and I'll answer them as best I can. So thank you very much for attending this. We will be sending out this recording to you, so you can view it at your pleasure. So thank you very much. I'll just hang on for a few questions. Thank you. Okay, well, as there are no further questions, have a great day, and I'll see you next time. Thank you very much. Bye.